All right, guys. Good afternoon again. So we're on this topic of matrices, and we are gonna just have a quick revision today, maybe less than 2 hours of work. So I'm gonna start as usual by going through this class activities, a very basic question, or 2 basic questions that I gave in the last class. The first one is this one right here. It gives us these 2 matrices, L and N. They are 2 by 2 matrices, and we're required to find that L minus N squared. All right. So let's go. Let's just do it over here. So question 1A. So L minus N squared is going to be the L matrix, which is 3, 2, 1, 4 minus N squared. Now, N squared does not mean you're going to square the N. It means you're going to multiply N by itself, N by N. So the N squared is N times N. So that's going to be minus 1, 3, 0, 2 times minus 1, 3, 0, 2. Maybe select smaller. And zoom in. Minus 1, 3, 0, 2. So we have to carry out this multiplication first, which is the N squared. So this is the L, and this is the N squared. So we have to multiply these 2 matrices right here. Remember, when you multiply matrices, you multiply the rows of the first matrix by the columns of the second matrix. All right? So I'm going to write back the next line. This is going to be the L matrix, 3, 2, 1, 4, minus, and I'm going to get a 2 by 2 matrix for this product with 4 values here, 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 and here. So let's zoom in on this multiplication now. So I'm doing this multiplication. So when you multiply matrices, you multiply the rows of the first matrix by the columns of the second matrix. And the row and the column that you choose is based on the position of the value that you're trying to get. So for example, this value here, first one right here, let me take this out. That first value there, it is positioned in the first row and the first column. So to get it, we're going to multiply this first row by this first column. And you multiply a row by a column by doing the first element in the row times the first element in the column. Then you add the product of the second element in the row and the second element in the column. So we see first element times first element, second element times second element. First element times first element, second element times second element. That will be -1 times -1 and 3 times 0. -1 times -1 and 3 times 0. And so that's how we're going to get the value for here. First element times first element, that's -1 times -1 is 1. And then 3 times 0. Second element times second element, 3 times 0 is 0. That is it for the first value. Then this value over here next, it is positioned in this first row and the second column. So to get it, you have to multiply this first row by this second column. You always take the rows from this first matrix, always take the columns from this second matrix. So now I'm multiplying that row and that column. Do it the same way again. First element times first element, second element times second element. First element times first element, second element times second element. So it's -1 times 3 and 3 times 2. The -1 times 3, -3, and the 3 times 2 is 6. So that's what we have so far. Then the value right here, the value coming right here now. That value is positioned in the second row and the first column. So to get it, we're going to multiply this second row by this first column. I multiply the same way again. First element times first element, second element times second element. First element times first element, second element times second element. 0 times -1 and 2 times 0. 0 times -1 and 2 times 0. 0 times -1 is 0 and 2 times 0 is 0. Then the last value over here is positioned in the second row and the second column. That's where it is positioned. So to get it, we multiply this second row by this second column. And the same thing. First element times first element, second element times second element. First element in the row by the first element in the column, second element in the row by the second element in the column. So it becomes 0 times 3 and 2 times 2. 0 times 3 is 0, and the 2 times 2 is 4. So this now becomes your n squared. So I'm just going to consolidate the values now in the next line. So it becomes 3, 2, 1, 4 minus, and this matrix now becomes 1 plus 0 is 1. -3 plus 6 is the same as 6 minus 3. 6 minus 3 is 3. 0 plus 0 is 0 right here. And 0 plus 4 is 4. And so now I'm subtracting these two matrices. They are the same size, so it's possible to subtract them. And all you do is subtract the corresponding values. So then it's going to be 3 minus 1. 3 minus 1 is 2. And then 2 minus 3. 2 minus 3 is -1. And then 1 minus 0. 1 minus 0 is 1. And then 4 minus 4. 4 minus 4 is 0. And this is your answer right here. For L minus n squared. But okay with that? But good?
Yes, sir.
All right. The next part wants us to find the values of x for which this matrix is singular. And the key word here is that they wanted values, plural. Values meaning more than one. All right? So they're telling us that this matrix right now is singular. What does singular mean? Singular matrix, remember, singular matrix has no inverse. The pen small over here. Singular matrix has no inverse. Has no inverse. And the determinant, or that is because the determinant is equal to 0. So what we know is that the determinant of this matrix is equal to 0. All right, so let's set it over here now. So this is what B. Yes, B of this first question, so B. So we know that the determinant of the matrix M is equal to 0. Determinant can also be written like this. This is another way of writing the determinant. But the determinant of M is equal to 0. So what is the determinant? The determinant is the first diagonal product minus the second diagonal product. You have to do this product first. That's x times x, that's x squared. Minus the second diagonal product. Mute your mic, please. That's a 3 times 12. 3 times 12 is 36. So that's the determinant of equals. Mute your mic, please. Mute your mic. And so you know, solving this for x. So you transpose the -36, and you will get x squared equals 36. And you would square root both sides to get rid of that square. Square root both sides. But what you must know is that when you calculate square root, it is plus or minus the value. And so the x is equal to plus or minus 6, but the truth of 36 is 6. I'm going to show you another way to do this part just to prove that it is plus or minus 6. Doing it another way. So I'm going to do this another way. So if we had x squared minus 36 equals 0, we can recognize this as the difference of 2 squared because that's a perfect square. Right now, the difference of 2 squared, it would be x squared minus 6 squared equals 0. Then if we factorize this as the difference of 2 squares, it will become x minus 6 times x plus 6 equals 0. Now remember, when you have the product of two values equals 0, either this one equals 0, so it is x minus 6 equals 0, or this one equals 0, which will be x plus 6 equals 0. So if I transpose this negative 6, I will get x equals that positive 6, or if I transpose this positive 6, it becomes negative 6. So x equals negative 6. So that's another way to look at it and to see why it would be plus or minus by factorizing this as the difference of two squares. All right. In any case, the x is plus or minus 6, and you should know that it is more than 1 because they use the term values there. Values mean more than 1. All right. And that is that. That finishes that first question. Everybody good so far? Everybody okay? Hello?
Yes, sir.
All right. The next part now is a typical question that they like to set in CSEC. They like to give simultaneous equations for you to solve using a matrices method. And they basically take you through the steps. First part is asking us to write it as a matrix or a matrices equation. All right, so let's look at it over here. So it is 2x plus 5y equals 6, and 3x plus 4y equals 8. And the first thing is to write this as a pair of matrices, as a matrices equation. So you have to check that you have the x value first, followed by the y value, which you do have in the first equation, and the x value followed by the y value in the second equation. So it is in that format that is friendly to set up as a matrices equation. And so part 1 as a matrices equation, it becomes a 2 by 2 matrix times a column matrix xy. And that's why you have to check that you have the x value followed by the y value. See? X value then the y value. And that will be equal to a matrix 6, 8 on the right side. All right, so this matrices equation now, we need the values for here. The values for inside here are taken from the coefficients up here. So the 2 and the 5 are the coefficient on the first line, 2, 5. And the 3 and the 4 are the coefficients on the second line, 3, 4. And so this is your matrix. So based on the fact that they call it A, X, and B over here, we can say that this is the A, this is the B, and this is, no, AX, sorry, AX and B. This is the A, this is the X, and this over here is the B. And that is the equation. This is the answer for that first part. All right, then we'll come to part 2. Part 2 says we have to calculate the determinant of the matrix A. Remember, this is the A now. We want the determinant of A. So the determinant of the A, remember, is always the first diagonal product. I have to do that product first. That's the leading diagonal product, or the main diagonal. So it's 2 times 4 is 8, minus the second diagonal product. And the product of the values on the second diagonal, that's 3 times 5, that's 15. And then the 8 minus 15 is negative 7. So the determinant of that matrix A is negative 7. All right. The next part now wants us to write the inverse of the matrix A, the inverse. All right. So that's quite simple again. Part B, well, this is part 2A. This is now part 2B. So A to the minus 1 is 1 over the determinant of the matrix A, which is this value coming under here, multiplied by the adjoint of the matrix A, which is AD. That's the adjoint. The D is because if you multiply the matrix the adjoint and the matrix, you're gonna get a diagonal matrix. That's why the D is there. All right. So how do we form this inverse now? So firstly, the determinant is coming under here. So it becomes 1 over -7 multiplied by the adjoint matrix. Now, how do we form the adjoint? You interchange the elements on the first diagonal. So those two values are coming back on the diagonal now, but they interchange place. So this is 2, 4 down. It's going to switch down to 4, 2 down. So 2, 4 on that diagonal becomes 4, 2. And then these two other elements on the second diagonal, some teachers call it the trailing diagonal or the following diagonal. Any word that means second is used to refer to that diagonal. So this element, those two elements are stay where they are and change sign. So the 5 stays where it is and change 5 in the same position to -5. And this 3 stays where it is in the same position, but it changes sign to -3. So that is your inverse matrix. But I can also divide each of these values by the -7 to write that one matrix. But if I'm going to do a calculation with an inverse matrix, I'm going to use this one and leave the fraction out here for last. So it becomes 4 over -7 first by dividing each of these values by this -7. So it becomes 4 over -7. It becomes 5 over -5 over -7. The negatives cancel. And so it becomes 5 over 7. Here again, the -3 over -7, the negatives cancel. That becomes 3 over 7. And then here now it becomes 2 over -7. So it's 2 over -7. So this really is the answer now. That's a to the -1. But if I'm using a to the -1, which oftentimes you will have to do in the questions, I'm going to use it as this one. I'll leave the fraction as for last. All right? That's what we normally do. Which is what we have to do in the last part, C. Which is to use the inverse matrix to solve for x and y, which is typically how you solve the equation. So let's set it up. So we have this equation up here, which is really ax equals b. And the xy here really is the x that you're trying to find. So let's set it up. So we have, I'm going to copy this back down here. This equation, so it's in front of us. Let's copy it back down here. For part C. All right, so we have this, right? And you really know trying to find the xy, make that the subject. How matrix transposition goes is that this A matrix comes into the front here as the inverse. The transposition is going to be that the x will be equal to a to the -1 times b. And the a, since it is in front of the x on this side, it has to go on the front on the right side as well. That's very important to know. See if I can find that question where you actually transposing this one instead. So this is in front, so it goes back to the front. The inverse goes to the front on the other side. All right? I've gone through the steps of why that is so in the class. So we're trying to find this xy now. So we need the inverse of this matrix times the b. This is the b. So this is the xy, which is the x. This is it now. Xy. That's what this is. It's equal to the inverse of a. But as I said, I'm going to be using this as my inverse. I can just copy it down right now. I'm using this. But I'm leaving the fraction for last. I'm using it right here. And I'm multiplying it by the b. Multiplying it by this b, which is this matrix. That is 6, 8. So you generally do the calculation here first and leave the fraction out here for last. Make it easier to do, easier to handle, less mistakes, less tedious. So xy comes equal to 1 over -7. And when I multiply these two matrices now, I'm going to get in two values, getting a column matrix. So I'm multiplying the rows of the first matrix by the one column of the second matrix. Right? So this first value up here that we want, let me take off this one. That first value here that we want is positioned in the first row and the one column. So to get it, we have to multiply this first row by this one column. So it's first element times first element, second element times second element. First element times first element, second element times second element. So it's 4 times 6 and negative 5 times 8. 4 times 6 is 24. And negative 5 times 8 is negative 40. The next value down here is positioned in the second row under one column. It means that we've multiplied this second row by this one column to get this value down here. Multiply them the same way again. First element times first element, second element times second element. So it's minus 3 times 6 and 2 times 8. Minus 3 times 6 and 2 times 8. Minus 3 times 6 is negative 18. And the 2 times 8 is 16. And so when we simplify these values now, we get 1 over negative 7 times. It becomes a negative 16. It becomes a negative 2. Negative 8 plus 16 is negative 2. And so now it becomes that xy is equal to, you're going to divide this negative 16 by this negative 7, and the negative is going to cancel, and you're going to get 16 over 7. You're going to divide this negative 2 again by this negative 7, and again the negative is going to cancel, and so you're going to get 2 over 7. And you have to pull out the value now. The x equals that. Therefore, x equals 16 over 7. And the y equals that, 2 over 7. And that is it. All right? Everybody good? Everybody okay?
Yes, sir.
All right. So that finishes that paper. What I'm going to do next now is some of the questions that I sent in the group. All right? I did some in the class. So now I'm going to look to do some of the other ones that I sent in the group, just for practice. This is all just for practice. I'm also going to see if I can find the specimen paper from the exam. In fact, let me see if I can find that first. I'm not sure if it is in this device. Syllabus. Thumbs up. CSEC maths. Let's see. Let's add maths. Let's add maths. Not seeing it. I'm not seeing it inside here. Only seeing add maths. Apparently, I don't have it in there. All right. So I need to ensure that you guys are exposed to that particular question. Where I have to use the other side. All right, I don't have it inside this device. Let me check over here. Let me just check over here a bit. I look for it before the class, but it just came to mind that I should really show you. I'm looking to have it somewhere else. Let's do a little quick search. Yeah, and see. Do I wait? I don't have it. I don't have it. All right. I think I'm gonna find it. Let's look in here so quick. I don't have it. All right, all right. I'll get to that. I'll find that question for you. I promise. I'll find that question. Well, let us look at the paper that I gave you. 2016. This one of the papers that I gave you, right? This is the May 2016 paper. And this is the Matrices question number 11. Exam you'll be doing will be 10 questions, but it's the older syllabus with 11 questions, right? And this is the Matrices question right here, part of it. It says, determine the value, say only one value this time, of x, so similar to one that we did in the class activity, of this x, such that it is singular. Remember, once it is singular, singular means it has no inverse. And the determinant is equal to 0. So use this for the calculation. All right. Also, when it has no inverse, the two diagonal products are equal. The two diagonal products equal. So if this is A, D, C, D, then the AB, no, the AD is equal to the BC. So this product becomes equal to that product as well. All right. That's another thing that's also good to use. So if you're using that method, this one, then this product will be equal to this product. So we can put this product first equal that product. So we could say 2 times x, that's this product, is equal to this product of 3 times 4. So 2x equals 12. And so the x equals 6 to divide by this 2. That is easy as that. Any question there? Easy stuff. What are to that?
Yes, sir.
All right. Next part now says N and P are two matrices, right? So this is the N, this is the P. And I want us to multiply them. So we did one a while ago, so we can go a little bit faster now. Because we've been doing this a lot, so we can speed it up a little bit now. At the same time, we just explained when we did the N squared in the question. So this really now is equal to 4, 1, 3, 2 times 1, 5, 2, 1. And again, you have to multiply the rows of the first matrix with the columns of the second matrix. All right. So we're going to get this being equal to a big 2 by 2 matrix with 4 values. 1, 2, 3, 4 values. But let's take them one at a time. So I want this value first, which is positioned in the first row and the first column. So to get it, you have to multiply this first row by this first column. And multiply them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 1 and 1 times 2. 4 times 1 is 4 and 1 times 2 is 2. 4 plus 1 times 1 is 2. Then this second value is positioned in the first row, second column. So to get it, you have to multiply this first row by the second column. Multiply them first element times first element, second element times second element. That's 4 times 5 and 1 times 1. 4 times 5 and 1 times 1. So the 4 times 5 is 20 and the 1 times 1 is 1. Then the next value down here that we want is the position in the second row and the first column. So to get it, we want to multiply this second row by this first column. And it's first element times first element, second element times second element. First element in the row and the first element in the column, second element in the row by the second element in the column. So it's 3 times 1 and 2 times 2. So 3 times 1 is 3, and the 2 times 2 is 4. The last value down here is positioned in the second row, second column. So to get it, we want to multiply this second row by this second column. And it's first element times first element, second element times second element. First element times first element, second element times second element. 3 times 5 and 2 times 1. 3 times 5 is 15. And 2 times 1 is 2. So we can write the final answer here for that product, which should be, this works out to be 6. This works out to be 21. This works out to be 7. And this works out to be 17. That's the answer right there. Very good.
Yes, sir.
All right. Down here says now, given that Pn, is what happens? You switch them around. So Pn is equal to this other matrix. And it said, determine whether matrix multiplication is commutative. The answer is no, because they're not equal. Right? So what I say, since NP is not equal to Pn, they're not the same, but this is what we got for this one. And that is what Pn. So they're not equal. This is NP. Since NP is not equal to Pn, then matrix multiplication is not commutative. So that's what commutative means. If they were commutative, then the result will be the same when you switch them around. Just like how 2 times 2 equals 2 times 3. Let's do a different number. 2 times 3 is 6, and 3 times 2 is also 6. In regular numbers, they are commutative. Multiplication is commutative in regular numbers. Same thing with positive, with plus, with adding. So 2 plus 3 is 5, and 3 plus 2 is still 5. So addition of numbers, addition of real numbers is also commutative. All right? But in matrices, multiplication of matrices is non-commutative, generally speaking. So that is that. Anything else they want us to do on this question? Yes, they want us to find the inverse of n. Let's write down what n is again. We have it right here. Try this in the first one. Just copy this one down. This is our n. When it's calculated inverse of it. All right, so let's go now. So the inverse of n is 1 over the determinant of n multiplied by the adjoint of n. So it becomes equal to 1 over, what's the determinant? This first diagonal product, which is 4, 2 is 8, minus this second diagonal product, which is 3 times 1 is 3. And they multiply that by the adjoint of n, the adjoint of n. We get the adjoint. Interchange those two. 4, 2 on the first diagonal, interchange them to 2, 4. They leave these two where they are and change the sign. So this one stays where it is and it becomes negative. And this one also stays where it is and becomes negative as well. And then this under here is just a 5. Let's put that in red. This under here is just equal to a 5. So the determinant is equal to 5. So now to get the final answer, I'm going to divide each of those values by that 5. So this is it. 2 divided by 5. You can write that as 2 over 5. Negative 1 divided by 5. That's negative 1 over 5. Then negative 3 divided by 5. And negative 3 over 5. Then 4 divided by 5. That's 4 over 5. And that is your inverse matrix n to the minus 1. All right, but if I'm going to calculate using n to the minus 1, I'm going to use this one and leave the fraction, the 1 over 5 for last, which is what we're required to do here. See, hence. The hence means you have to use this result. I use the n to the minus 1 to solve for x and y. So it's a simple, same transposition. This matrix will come in front here as the inverse. All right, so this equation will transpose it in matrices. The xy becomes the inverse 4, 1, 3, 2. I'll put on the minus 1 on it. So you see the inverse I'm talking about, multiplied by the 1, 2. So I've taken this matrix and I brought it to the front on the next side as the inverse. All right. And so it is the inverse of n, which is right here, that is going there. So then this becomes equal to 1 over 5 times 2 minus 1 minus 3, 4. This is this matrix, the inverse right there. And then multiplying that inverse matrix by the 1, 2. 1, 2. And generally, I do this calculation in here first. All right, so it's going to become 1 over 5 times a column matrix. Let me zoom in. So again, we're multiplying the rows of this matrix by the 1 column to get this column matrix with 2 values. Let's do the first one first, right here. That value is in the first row and the first column, or the 1 column. So multiply this first row by this 1 column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 2 times 1 and minus 1 times 2. 2 times 1 is 2 and minus 1 times 2 is negative 2. Then this value down here is positioned in the second row, 1 column. So to get it, we'll multiply this second row by this 1 column. And it's negative 5 times 1, that's first element times first element. 4 times 2, that's second element times second element. Let's put in the values now. Minus 5 times 1 is negative 5. And 4 times 2. Second element times second element is 4 times 2 is 8. So this then works out to be 0. And this is 8 minus 5 is 3. And it's 1/5 outside that. And so 0 divided by the 5 here is 0. And then 3 divided by 5 is 0.6. So I can put 2 or 5. So it is the xy that is equal to that. So explicitly state x now. So x equals 0 and y equals 3 over 5. And these are your answers. Are you okay with that? You stand done. Are you okay with that?
Yes, sir.
All right, so that was 2016. Let's see what other paper I gave you to do. Let's see what other paper. If you remember what other paper I gave you to do, you can just tell me, you know. What other paper did I give you to do? Let's see. Let's see. 2016.
Sir, but the June, all right.
I'll give you January.
May 2014.
Yeah, I want to do the one that I gave you from in the week first. So
I don't remember that one, sir.
I think I gave it January 2016. Let me look for it. January 2016. Search for it here. January 2016, paper 2. That's one here. Let's look at this one. Question is more than likely at the back. There you go. Almost the same thing asking in these questions, you know, almost the same thing. Right? It's almost the same thing. So once you practice and so on, you're not gonna have a problem. This question says, this matrix is defined as this. And it says, determine the value of P if it is singular. Same thing. Singular mean has no inverse. Because the determinant is of M is equal to 0. When that is the case, this product becomes equal to this product. All right? So if you do when that is the case, the diagonal product becomes equal. So AD becomes equal to BC. So this product will be A times D. So we can say 2P times 1 becomes equal to 4 times negative 3. 4 times negative 3. All right, so this becomes 2P equals negative 12 divided by this 2, the P equals negative 6. That is it. Done. Next part. Next part gives us these 2 by 2 matrices, and I want us to calculate 2 times the first one plus the second one. So this will basically be 2 times the first one, 1, 2, minus 4, 3, plus the second one, 5, minus 1, 0, 3. So 2 times the first one first will become 2, 4, minus 8, 6. Remember, you multiply this 2 by each of the values inside here. Right? So the 2 times 1 is this 2. The 2 times 2 is this 4. The 2 times negative 4 is this negative 8. And the 2 times this 3 is 6. And then to that, we're adding B. 5 minus 1 is 0, 3. And when you add matrices, you add the corresponding values. So we can put the answer right here. So it's 2 plus 5 is 7. 4 and minus 1 is 3. 4 minus 1 is 3. Minus 8 plus 0 means minus 8. And 6 plus 3 is 9. And that is it. Then they want us to determine B to the minus 1. All right. So remember, this one is the B one, right? So B, remember, is 5 minus 1, 0, 3. I want the inverse of it. So B to minus 1 is 1 over the determinant of B multiplied by the adjoint of B. So it's 1 over the determinant. Determinant is this product minus this product. So this product first is 5 times 3 is 15 minus this product, 0 times negative 1 is 0. So the determinant is just 15 multiplied by the adjoint. We're going to interchange these two elements on the first diagonal, interchange them. So the 3 goes here and the 5 goes here. Leave these 2 on the second diagonal where they are, change the sign. This negative 1 becomes a positive 1. This 0 remains 0. And so now I'm dividing each of these values by 15. So it becomes equal to, so 3 over 15 becomes 1 over 5. 1 over 15 is just 1 over 15. Then 0 over 15 is just 0. Then 15 over 5 is 1/3. 15 over 5. 5 over 15, sorry. 5 over 15. 5 over 15 is 1/3. I'm just going to write 1/3. 1/3. Very good. Go so far? Easy stuff. I think some of the more recent questions are a bit more interesting than these. You know. And here, let's almost calculate x1. So the same thing again. This is the B, you know. This is the B that we just calculated. And see here. 5 minus 1, 3. That's what we have here. So based on this is the B. This is the B. I want to make this a subject. That B to the minus 1 coming in front of this. So the xy is going to become e to the minus 1 times 9, 3. And the b to the minus 1, we just calculated it up here or whatever. We're going to use this one. Let's use this one. 1 over 50. Let's copy it down. I'm using this one fraction on the outside. I'm going to write this as 1 over 15 out here. Shift this over. That's the inverse of b right there. Times 9, 3. I leave this fraction for last. Multiply these two matrices. So the rows of the first matrix times the one column. This becomes equal to 1 over 15 times. I get two values again. So it's this row times this column for the first value here. So it's 3 times 9 and 1 times 3. So 3 times 9 is 27. 1 times 3 is 3. The second value down here now is this row times one column. So 0 times 9 is 0. And the 5 times 3 is 15. I like these values. Because this then comes equal to, this is 30. And then 30 divided by the 16 is 2. So this becomes 2. This is supposed to be a 50, not 5. 15. 5 times 3 is 15. So 15 divided by 15 here is 1. That is xy. And therefore, you can say the x equals 2 and y equals 1. That's it. Done. Done. Let's look at another question. Let's look at 2017. God, I've given, let me see. I've given it 2017 as well. A very easy topic in a guy. Once you catch it, you're good to go. 2016 or 2015. We did 2017 already. We got 2015. For January 2015 first. All right, it's 1 year. January 2015. Everybody okay so far?
Yes, sir.
All right. So that one we did in class. Almost the same thing. All right, same thing. This one, same thing again. Let me skip over this one. That is basically the same thing. Let's look at June. June 2015. Or should I put May 2015? Not in a CSEC. All right, let's put May 2015. Nah, it's coming up. Let's get it another way. Mr. Mike, please, Mr. Mike. Mr. Mike, please. Somebody's mic is open. All right, let's go. In 2015. They say basically asking the same thing in all these questions. So shouldn't have a problem. I guess the only thing is the conformable question. You can maybe just do one of them for the purpose of the session. And those tend to come in the more recent exams. All right, about matrix multiplication being when it is conformable and so on. So this one says we have to calculate this product again. And then to show that it is non-commutative, AB not equal BA. So I'll just run through it quickly. I'll basically more of the same, just different values. I think I might need to do one of the more recent papers to get a question with the conformable or not. So AB would be 1123 times 1201. All right, multiply them the same way. Rows of the first matrix times column of the second matrix. And you get in a big 2 by 2 matrix for your result. And the first value here is in the first row and the first column. Using this first row with this first column. First element times first element, second element times second element. So it is 1 times 1 is 1, and 1 times 0 is 0. And the value over here is this first row, second column. That's where it is positioned. First row, second column. So it's first element times first element, second element times second element. So that becomes 1 times 2, 1 times 1. 1 times 2 is 2, and 1 times 1 is 1. And the value down here is in the second row, first column. So to get it, multiply this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. 2 times 1, 3 times 0. The 2 times 1 is 2, and the 3 times 0 is 0. And the last value down is positioned in the second row, second column. So to get it, we have to multiply this second row by the second column. So it is 2 times 2 and 3 times 1. 2 times 2 is 4. 3 times 1 is 3. So we can write by the final answer now in blue, which is, this is 1. 1 plus 0 is 1. 2 plus 1 is 3. 2 plus 0 is 2. And 4 plus 3 is 7. That is it. It says show that the matrix product AB is not commutative. So I already have AB. Of A and B is not commutative. You already have AB. So when you calculate BA, start working out BA. It will be 1, 2, 0, 1. That is the B first, the B in front now, times the A, which is 1, 1, 2, 3. That will be the A second. And then I would start the calculation. I don't need to calculate everything to prove it, because I'm using again the rows and the columns. The first value here will be this row times this column. So it will be 1 times 1 and 2 times 2. So the 1 times 1 is 1 and the 2 times 2 is 4. And this value would work out to 5 something. And since this one started at 5, this one started at 1, it means that they're not equal. So I'm going to write not equal to AB. So BA is not equal to AB. I don't need to work out all the values. And once the first value is different, then the whole matrix is different. So therefore shown. I've shown it. All right. If you feel compelled, you can maybe work out all the values, but I think this is sufficient. All right, because 5 is not equal to 1. It's right here. 5 is not equal to 1. The one that is in that position is 5 right here. And that makes the matrices not the same. It wants us to find the inverse of A. The inverse of this first one. 1, 1, 2, 3. So let's go. Let's choose a purple. A is a matrix 1, 1, 2, 3. And so we're doing A to the minus 1, which is 1 over the determinant of A times the adjoint of A. So it's 1 over the determinant is this product. First diagonal product is 1 times 3 is 3, minus this product. Second diagonal product is 1 times 2 is 2. Multiply by the adjoint. So you interchange the elements on the first diagonal. So 1, 3 becomes 3, 1 down the diagonal. Leave these two values where they are on the second diagonal and change the sign. This 1 becomes negative 1 up here. This 2 becomes negative 2 down here. This under here is just a 1, you know. This under here is just a 1. So you're not going to be changing the values of any of those in the matrix. And so it becomes 3 minus 1 minus 2, 1. This matrix. That's the answer. That's A to the minus 1. All right, down here again, singular matrix again. No, yes. See, this one I don't say it's singular, no. It tells us that the determinant is 0. And the determinant is 0. Again, it means that it is singular. And it has no inverse. So they can't give any one of these 3 things, and they mean the other 2. All right. So sometimes they tell you the determinant is 0. Sometimes they tell that it is singular. Sometimes they tell you that it has no inverse. They're all talking about the same kind of matrix, a singular matrix. And when that is the case, the diagonal products are equal. So we can say AD equals BC. This is AD. And this is BC, because the matrix notation is normally A, B, C, D. So this diagonal is AD. This diagonal is BC. All right. So I say this product, which is 2x times 3, is equal to this product, which is 9 times 2. So the 2x times 3 is 6x. And the 9 times 2 is 18. And divide by the 6, 18 over 3. 18 over 6 is 3. So x equals 3. That's it. All right. I want us to do one of the questions about the matrices being non-conformable. All right. So let's look through and see which one it is before finish. I don't think we have to do much more work today, because you realize that all the questions are basically the same. I just want us to do one about being conformable or not, which is one of the more recent exams. All right. So I've done one in the class, but I'm going to do one now still. Let's look at 2024. I don't know if I sent you this paper. Maybe I did, maybe I didn't. But let's look if one is on that. Let's look at the matrices question. And sometimes the matrices question will be a transformation question, which is the topic that we're doing next. All right, so let's see. What was on this one? 2024. Reverse of L. This one is a straightforward. All right, this one is a straightforward one, right? All right, let's run through it quickly. Or this part of it. This part says the determinant is 24. So it means that this product minus this product is 24. The determinant is 24. The determinant is equal to 24. What is the determinant? This product, which is 6 times negative V, minus this product, which is 2V times minus 5. That is equal to 24. This is negative 6V. This minus and minus make this a plus. Minus times minus becomes a plus. The 2 times 5 is 10, so it's plus 10V equal to 24. So 10 minus 6 is 4V that. So this is now 4V equals 24. Divide 24 by 4, we're gonna get 6. So V equals 24 over 4, which is equal to 6. So V equals, but understand that?
Yes, sir.
All right, good. Then this one wants us to do this product, which we have done a number of them. I'm gonna skip this one. I want us to do one that we have not doing in inverse of here. So we do a number like this already, which is more the same. So let me look at a different paper. Let's look at a different paper. Let's look. I want to do one that we're talking about conformable and so on, just to make sure at least we touch one of those. So let's look at January 2024. If I have it here, it should be inside here. No, not paper one, paper one. Paper one. Should be inside here somewhere. Here we go. 2024. All right, let's see what is on this one. We don't find one on this one of the Matrices. So we did a simultaneous equation already for classwork. So you can skip over this one. And then this one again, another, I think we did this one in the class. This one don't have anything about the conformable on it, right? So I want to skip over this one as well. And let's look at 23 then. Let's look at 2023. 2023. I'm searching for one of those I talk about. The matrices multiplication being conformable or not. Just to get a little revision on that. They don't ask much more things in matrices really, you know. They don't ask a lot of stuff. Most of the questions really asking the same thing. So this one said the determinant is 5. It was the determinant is 24. All right, here we go. Can they look at this one? We practice about when the matrices multiplication is possible or not. Not possible, right? So we have a 2 by 2, 2 by 2, and a column, and a 3 by 2. It's a 3 rows by 2 column, right? Matrix. 2 by 2, 2 by 2, and it's a 3 rows by 2 column matrix. All right, let's see what it says. It says, explain why the product QS is not possible. Explain why QS is not possible. Right? When it's not possible, we say it is non-conformable. Non-conformable or not conformable. Why is that? Because QS, in QS, you'll be multiplying a 2 by 2 with a 3 by 2. Let's write it out. QS will be a 2 by 2 times, and the S will be a 3 by 2, 3 rows with 2 columns. Will be a 3 by 2. So for the matrices multiplication to be possible, for it to be conformable, the number of columns in the first matrix, which in this case is 2, must be equal to the number of rows in the second matrix, which in this case is 3. So they are not equal. Because they are not equal, it means that the matrix multiplication is, the matrices are non-conformable. And that's why it is not possible. Because the number of columns in the first is not equal to the number of rows in the second. So this is it. It is not conformable, meaning the number of columns in the first one is its Q is not equal to the number of rows in S. All right. And so we can write that. Explain why it is not possible. This is the reason now. Not possible because non-conformable. Not possible means non-conformable. So not possible. QS, not possible because, let's write it here now. Put it in blue. Number of columns in Q, which is 2 of them, is not equal to number of rows in S. I have it in the diagram right here. This is the number of columns in Q, that's the number of rows in S. They are not equal. Then this one says, state the order of the matrix product SR. What would be the result of SR? So SR would be, the S would be at 3 by 2. It would be at 3 by 2. That's what the S would be, the S. And the R right here would be at 2 by 2. And we multiply a 3 by 2. Let's put it right here. In this case, the number of columns in the first matrix is 2. And the number of rows in the second matrix is also 2. Them equal. So therefore, this one is possible, but this one is possible. Or we say it is conformable. They are conformable. The matrices are conformable for multiplication. When they are conformable, the resulting matrix is going to take the same number of rows from the first matrix together with the same number of columns in the second matrix. That's going to form the resulting order. That's where the result is going to come from. So it's going to be a 3 by 2. A 3 by 2 is going to be a result. Want to go to that?
Yes, sir.
All right. And that's what I wanted to do. And this is asking us to multiply these two 2 by 2 matrices, Q and R. So I'm going to skip over that part, right? But that is just more of the same that we've been doing all day. So I'm not going to skip that. So basically the same thing. We did one like this a while ago. So the determinant is 5. So it means that this product minus this product is 5. Let's look at it. 4 times X minus, this is -7 times -1. So don't get confused. -7 times -1. That is equal to 5. Determinant is 5. This is 4x minus this -7 times -1 becomes a +7. This is equal to 5. Carry this 7 over here, add it to the 5, we get 4x equals 12. And then divided by this 4, we get x equals 3. X equals 3. All right, that is that. All right. I'm trying to see if we can get one with a equality of matrices example, right? Which is one of the ones that I think I sent recently, like 2014. So let me look at the 2014 and see if I see one of those. I just want to make sure that we cannot touch before the class is out the various types of questions that I tend to set. So let me look at 2014. There's one on 2014. This is January. Let me see if it's January or June 2014. Let's see. One of the more recent ones that I sent. Equality of matrices. This is not this one. This is transformation, our next topic. Let's look at June 2014. I just don't remember which one specified some guys. So just bear with me, please. Let's look at June 2014. See if it is that one, 2014, right here. Nah, same thing, this one again. Now let's look at 2015 then. One that I gave recently. Let's look at 2015. There's a particular type that I'm trying to find. Should have maybe have it prepared before the class, but that's where it goes. Didn't get the chance to go through. Let's look at 2015. But I have type of question I'm thinking about in my head. All right, let's see. No, this is the same thing. All right, I know I'm gonna find it. I think I know I'm gonna find it. Hold on a second. Just give me a second. 2012, May 2012. There's a question on May 2012 that I want to show you. We can actually use the inverse matrix. 2012. May 2012. All right, let's see. All right, let's see. Bum, 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 bum. Right here. Right. Wanted to show you this question. Some persons did it, got it right, which is good. But actually, all of this. Let me split the screen and run through it. I mean, not to worry, I want to practice these things a lot more. Like we have to get everything all now because we are gonna do so many questions and all these papers, right, in preparation for the exam. I'm sure that what I'm trying to find even now, we will cover. We definitely will cover and do those examples. All right. Well, let's look at this question. It's an equality of matrices question, right? It gives us this question, this equation, and it's asking us to find the A and the B. And look at this matrix that it is equal to 2, 0, 0, 2. All right, so let me set it up for you now. So it is A minus 4, 1, B times 2 minus 4, 1 minus 3. And we are told that it is equal to 2, 0, 0, 2. So it means that when I multiply this matrix by this matrix, this is the result. All right? So the rows of this matrix times a column of this matrix equals that. Now, I know that this 2 is the product of this row and this column. I also know that this 0 is the product of this row and this column. So I could use any one of those 2 to get the answer for what A is. All right? So if I'm using the 0, and this is those 2 that I'm using. In that case, it will be the A times -4, so negative 4A, and the -4 times -3 is positive 12. That is equal to the 0. To transpose the 12, I will get -4A equal -12. Divided by -4, negatives cancel, and I will get A equals 3. All right? Or I could use that first row with this first column with the 2. Let's do it and see. We get the same answer. And in that case, it will be the A times the 2, which is 2A, and the -4 times the 1, -4, that will be equal to 2. When I transpose this 4 over here, I will get 2A equals 6. Divided by this 2, I will get the A equals 3. All right, so you have those options. Then now for the B, I have to be using this row for the B. If I use that row and this column, I'm getting the 0. So let me just divide the screen right here and say I could use that row and that column to get the 0. So with this 1 times this 2, which is 2, and this B times this 1 times B is B. That will be equal to this 0 over here. And so transpose the 2, I will get B equals -1. Or I could use that row with this column be equal to that 2 right there. So this row times this column is equal to this 2. So I could do it again over here and say, that case, it will be 1 times -4, -4, and B times -3 is -3, and that will be equal to this 2 out here, 2. That minus, what did I do? 3B, -3B. B times -B is -3B right here. 3B. So what I could do is transpose this 3B over there, this side, and make it positive 3B. And take this 2 and transpose it over here, and I will get -6. I have a wrong answer here. This is -2, not -1, -2. Right, so I will transpose this 2 now over here and get -6. -2 and -4 give me -6. Then I will divide by this 3. I will get B equals -2 just the same. All right, so you see any point, any value you choose to use, you will get the answer. All right. Now that finishes the first part. But this question now says, interesting thing with this question, it says hence or otherwise. We have to write down the inverse of this matrix. Now the hence is basically saying we have to use this result, use this to write down the inverse of this matrix. Now, how could you use the hence method? The otherwise method would be to calculate the inverse in the normal way. 1 over the determinant times the adjoint. All right? That would be the otherwise method right now. I want to use the hence method to do it. So in other words, I want to use this information to do it because it says hence. So let me set it up for you now. So it's basically like I'm writing back this equation. I want to just point something out to you. So let me write back this equation that they gave us. As I'm going to use the hence method. I'm going to use that result and put it here. So this is the equation that we have. We'll take these off. All right. Now we work toward the A. The A is this 3. So I'll take the 3 and put it right here for the A. So let's change this to a 3. And then this B is negative 2. I'm going to change this now to a negative 2. Negative 2. All right. Now, the interesting thing that I want to point out to you with this matrix, guys, with this matrices equation, look at it carefully, is that this matrix over here is almost the identity matrix. No, it's actually 2 times the identity matrix. Because the identity matrix is 1, 0, 0, 1. And so that is 2 times the identity matrix. That's what it is. Now we know that a matrix multiplied by its inverse gives it the identity matrix. So watch this now. It means that to get this to be the identity matrix, I will take a half on this side. But if I take a half on this side, I must take a half on this side as well. All right. And when I do that, what will happen? This will become a multiply and a half by this matrix, you know. And when I multiply the half by this, it will become the 1, 0, 0, 1. 1, 0, 0, 1, which is now the identity matrix. This is now the I matrix. Let me put it in there. This is now the I matrix. All right. So this matrix, I'm keeping as it is because that's the one, the inverse of this. So I'm keeping this as 2 minus 4, 1 minus 3. This has to be the inverse now. That calculation has to be the inverse of this one. Because it will become 3 divided by 2 is 3 over 2. I could put 1.5. 3 divided by 2 is 1.5, whichever way, 1.5. And then this divided by 2 will be negative 2. This divided by 2 will be 0.5. This divided by 2 is negative 1. And so, since the product of these 2 matrices equals the I matrix, it means that these 2 matrices are inverses of each other. They are inverses of each other. And since I want the inverse of this one, if this one is A, if this one is B, then this must be B to the minus 1. So this should be the answer. Gotten it simply by taking the original equation that they gave us and make the right side be equal to the identity matrix. And so these 2 matrices now that are multiplying must be inverses of each other. So since they ask us for the inverse of this one, the answer is this one. So we can literally write it. That will be the hence method. So we could say inverse of 2 minus 4, 1 minus 3 is this one. 1.5 minus 2, 0.5 minus 1. That's the inverse of this matrix. And if you want to, we could calculate the inverse of this matrix the normal way. Now, let's look at it. Let's calculate the normal way. This is the hence method we just did, right? Let's calculate this is the hence method. We just use hence. Here we just use hence to do it. We don't actually calculate in the inverse. We just use hence. Starting from the original equation, we made the right side the identity matrix. And then we know that the product of 2 matrices that are inverse of each other will be equal to the identity matrix. And so the inverse of this one is this one. And that's how we get the answer, right? So we're saying that this is the answer. This right here. But let's calculate the inverse now using the otherwise method, which is the normal way. And the matrix we're talking about, remember, is the 2 minus 4, 1 minus 3. So if we calculate in the inverse, it will be 1 over the determinant, which is this product. 2 times negative 3 is negative 6, minus this product, which is 1 times negative 4 is negative 4. This minus here become a plus. Let's put the plus in there. And you multiply that by the adjoint matrix, the adjoint. So you interchange these 2, split them around. We get minus 3, 2. And you leave this one where it is and change the sign to a 4 right here. Leave this one where it is and change the sign to a -1 right there. Now this become -6 plus 4, which is -2. So this actually works out to 1 over -2 times -3, 4, -1, 2. And they're ready now. And dividing this -3 by this -2 becomes a positive 3 over 2 or a positive 1.5. Divide this 4 by this -2 becomes a -2. Divide this -1 by this -2 becomes a positive 0.5 because the negatives cancel. And then this -2, this 2 divided by this -2 becomes a -1. And so you're getting the same answer as I have up here. See there? Let me copy it down. Doing it another way, the otherwise method, we're getting the same answer. See? Same answer as before. But understand that? Just wanted to show you that thing, that sometimes you get questions where you can actually apply your knowledge, apply the knowledge about the identity matrix, as I did right here. That the product of a matrix equals the identity. And from time to time, they set questions like this, where you are able to apply your knowledge that the product of a matrix and its inverse is the identity matrix. Don't think I want to do anything else for the day, anything else. I think we have covered some of the main things that I would want to do today. All right, guys. It's almost 2 hours now anyway. It's about an hour and a half. Okay, buddy? I think I'm going to stop it there. All right, so we're going on to a new topic tomorrow. I want to see a lot more matrices. We're going to see more matrices in that topic, which is transformation. Not only matrices, we want to see also construction. We have to construct, transformations as well as calculate transformation. So it's going to be a nice, fun topic. It's a big topic. A topic where you can actually get 2 questions. Most times there are 2 questions on the exam paper in transformation, right? And I can even just show you quickly on the most recent exam, which is the May 2024, which is right here. Where are you? Just showed me the while ago. Right here. Right. Usually 2 transformation questions on the paper. All right, it can be 2 transformation questions. So this one didn't set a transformation question in section 2, but oftentimes the second question, the matrices question is a transformation question in section 2. Let's look at January 2024. That's another transformation. Let me see. But that's what we've been doing in recent times. You're getting 2 transformation questions possibly on the paper. All right, but you see it. I'm not seeing it now, but you see it. All right, but it's a very nice topic. It's a short topic, and we want to make it a short marks topic as well. All right, guys, so I'm going to end it there for today, and I'll send the video in the group for those who are not in attendance. So many persons absent today. I wonder what it is. So many persons absent today. But anyway, we just got to do what we got to do. Got to do the job. All right, guys. So see you all tomorrow and Monday. And we're going to be doing a really, really important topic. Because as I said, there's a possibility that you can get 2 of that, 2 questions on that topic on the same exam paper. 1 in section 1 and 1 in section 2. All right, so see you in class. Bye, everybody.
Bye, sir.
All right, then, bye-bye.